Good evening, everyone.
Good evening, sir.
Good evening.
Good evening, sir.
Okay, so let's start now. Okay, in today's class, we will be continuing with physics. So in physics, which we were doing about the revision of human eye and colorful world, right? We started with the revision of human eye and colorful world. And in that, I think we discussed about dispersion of light. In the last class, we had discussed about dispersion of light. So, Abhinav, can you tell what is dispersion of light?
So light gets refracted when coming upon like when
Light
it's
gets
incident to a medium
refracted.
in a prism.
No. Anyone? Dharya? Dharya, can you answer? Dharya? Moksha? Moksha? Okay, Moksha, just answer. What is dispersion of light? Good evening, Huria. Ishak, can you answer? What is dispersion of light? There
Good
is
evening,
not
sir.
answer. Yeah, good evening. Sumuk, what is dispersion of light? Okay, a white light disperses into rainbow colors. So that means the splitting of white light into its constituent colors is called as dispersion of light. Okay. The constituent colors, they are the rainbow colors, that is VIBGYOR. If we try to draw the VIBGYOR or the constituents of colors, so during the, okay, seven colors are there. Fine. Okay, who will explain why there is dispersion? Arav? Arav, can you explain why there is dispersion of light? Arav?
Sir, can I?
Yes.
Sir, because different colors have different wavelengths and uh, refractive index, so they divide.
Okay, very good. Yes, continue. Different colors have different wavelengths. So, yeah, Rijwana. Rijwana, can you answer?
Sir,
Yeah, can you answer?
can you repeat the question?
What is the cause of dispersion?
It's when a light ray like falls on a particle.
Okay, when light falls on a particle, then what happens?
Then it scatters.
Okay, let's try to understand again. how the 7 colors are split up, right?
Sir, can I try answering?
Yes, try it out, sure.
Sir, because the colors have different speeds in the prism, so they refract in different directions or in different speeds.
Yeah, different colors travel with different speeds in a prism. Okay. Whereas in air, all the colors they travel in air, all the colors have the same speed, but when in glass prism or any other medium, the different colors they travel with different speeds of light. Okay. So different colors have different speeds, hence they have different refractive indices, and hence they split by different or they bend by different angles. So due to this, we have this of light. And also one important thing you must remember here, that refractive index. A refractive index is inversely proportional to the wavelength. That means the color which has the maximum wavelength will will have the minimum refraction, will have the minimum deviation. The color which has the minimum wavelength will suffer the maximum refraction. Okay. So here we had seen among the 7 colors, the story of 7 colors we were going on, Vibgyor, and I told you to remember something like this. Voila has many friends. Or maximum friends. Okay, so Voila has maximum friends. So remember like this, so you will be able to recall. Voila means violet, has
Maximum
maximum
frequency.
F for frequency. So violet has the maximum frequency, that means it will have the minimum wavelength, and minimum wavelength, that means this violet color will suffer the maximum refraction. Okay, so the next phenomena we were just about to discuss was, I think, scattering of light. Right? Had we started with scattering of light? See, the next phenomena was scattering of light, and based on the scattering of light, we try to explain the color of sky, the color of sun, various other things can be explained on the phenomena. So, scattering of light. This phenomena is very special. This phenomena is observed. Also, with this phenomena, we observe the Raman effect from Raman. So, scattering of light, it is the moving of light in perpendicular directions. The moving of light into perpendicular directions when light falls on particles of size approximately the wavelength of light. Okay. So whenever light falls on such small particles, tiny particles, okay, so it will move in its perpendicular directions. It happens something like this. So here you have tiny particles. The size of the particle is approximately the size of the wavelength of light. So when the light comes over here as a wave, now this light, it gets scattered in perpendicular directions. It moves in its perpendicular directions like this. Okay. So this phenomena is called as the scattering of light, and it is also called as the Raman effect. Okay. That when light falls on tiny particles which are of the size of which are of the size of the wavelength of light. So they call scattering. Now here, if we discuss about the wavelength of the light, so wavelength of the visible light, it ranges from 350 nanometer to 450 nanometers, right? The wavelength of light, it ranges from 350 nanometers to 450 nanometers. That means sorry, not 450, it's 750. Okay, 450, not, it's 350 to 750 nanometers. Now the particles, if the particles are of the same size, then the light will then there will be scattering of light. Now our air is made up of the gases nitrogen, oxygen, carbon dioxide, water molecules. So these are the gases which make up our Earth's atmosphere. And the size of these gases is very small. The size of these gases is very small. It is nearly about 200, 300 nanometers. Okay. So which color do you think will be scattered the most? If I say that the size of these
Violet.
molecules is small, about 300 nanometers. So which colors will be scattered the most?
Violet.
Yeah, violet. Definitely violet, indigo blue. These colors will be scattered the most, and this red color will be scattered the least, as it has a high wavelength of 750 nanometers, which is almost double of the size of these molecules. Okay. So due to the molecules of air, the smaller wavelengths are scattered, and that is the reason we say that violet color which is scattered the most. Okay, then followed by the indigo and blue color, and that is the reason we observe the color of the sky to be blue in color. Okay, now after this, today we had to do the phenomena of atmospheric refraction. Okay, this was also we had discussed in the last class. Atmospheric refraction we haven't discussed. So let's start with atmospheric refraction. So as the name suggests, atmospheric refraction means refraction through the Earth's atmosphere. So what are the different phenomena that occur or that we see due to the refraction through the atmosphere? Okay. So one of the phenomena that we observe due to atmospheric refraction is the twinkling of stars. See, how do stars twinkle? An important phenomena we observe here as twinkling of stars. So see, how do stars twinkle? You have, sometimes you observe here a star and then it disappears. Sometimes you observe here a star, then it disappears. You observe here a star, then it disappears. Then again appears. Okay. So in the night sky, we observe a star and then it disappears. Something like that if you observe. So we call it as the twinkling of the stars. Right? I think everyone has observed about the or heard about the morning star and the evening star.
Yes, sir.
Okay, so what is morning star?
Isn't it supposed to be Venus?
Yeah.
Sir, is it Venus? I heard it's Venus.
Yeah, Venus. Venus is the morning star. Why do we call it as the morning star?
Because like before sunrise, or like when it's sunrise, it appears. It's the last star to appear.
Yeah, it's the last star to be seen in the sky. That's why we call it as the morning star. Since as the morning comes, all the stars start disappearing. So during the morning time, this is the last star to be observed. That's why we call it as the morning star. Then we also call it as the evening star. Okay.
First,
Yes.
first star to be seen.
Yeah, it's the first star to be observed in the evening. In the evening, so that's why it is also called as the evening star. So, however, we are calling it as a star, but we know that it's not a star; it's a planet. Right? Venus is a planet, and it's not a star. Okay. So, do we ob- do we observe twinkling effect in Venus also?
No, sir.
Do we?
No, sir.
No. So why no twinkling here? No twinkling in Venus. But if you observe pole star, has anyone observed pole star?
Yes, sir.
Okay. Pole star, or if you observe stars of uh, Saptarishi, if you observe the stars of Orion, so they appear twinkling. The pole star appear twinkling, but this morning star, Venus, it doesn't appear to twinkle. Can anyone say? Okay.
Sir, Venus is a planet, that's why it did not twinkle.
Just, just 1 minute. Just 1 minute. Okay. So, yeah. What happened?
It's much closer than the stars.
Pardon again. It's much
Venus is
closer.
much than the stars.
So why? What is the difference then? What happens if it is closer?
Sir, Venus is a planet, not a star.
So what is the difference? Both are emitting light. Both are providing the light. Light is coming from both of them.
Sir, I guess for stars light it gets the light so weak it gets dispersed, I guess. I mean it gets refracted when coming in contact with our atmosphere.
It gets refracted with
Atmosphere.
atmosphere, and the Venus light also comes through the same atmosphere. So does it
But
not get
it's much
refracted?
but it's much closer, right? So we
Sir,
could
So
I
yeah.
think it has a different wavelength than other
No,
stars.
no, no. So here we understand first of all two concepts. One concept is an extended source of light, and point source of light. So an extended source of what is an extended source of light, or what is a point source of light? An extended source of light is the source of light which is quite big in size, and a point source of light is a light which is very example. You can consider like this. If this one, you can observe here a dot. Okay. If I make here another dot, let's say make here another one. Now I make this one. See this one. Okay. Now if you observe the point sources, they are very small. You can't concentrate here. However, there is no twinkling effect. But the objects which are very small in size, they are called as the point sources of light. The sources of light which are very small in size, whereas the extended sources, they are quite big in size. So that is the difference. However, the stars are big, but since they are very far off, so they appear to be point sources of light. They work as the point sources of light, whereas the planets, they are close and hence they appear as extended sources of light. So first point is that planets are the extended sources of light and stars are the point sources of light. So see what happens now. When the light passes through the Earth's atmosphere, Okay, see. What happens if we get light from a point source of light? What happens if we get light from an extended source of light? So here you have light falling from a point source of light, and here we have a light coming from an extended source of light. See. बताओ सबको फंसा के अपने को खींचना रहेगा। Okay, see here. So as you can see, I have taken here three sources of light. A point source of light I have taken two extended sources of light. So when the light comes through the Earth's atmosphere, now see what happens when the light comes through the Earth's atmosphere. So all the light, they suffer refractions. Light rays, all these light rays, they suffer refraction and reach our eyes. Here also, this light also suffers refraction and comes
Sir, yes. Try.
Sir,
I think sir left the class.
sir left the meeting.
Thank you everyone for waiting. There was some network issue. Let's continue again.
Yes. Sup guys?
See, the atmosphere, it continuously changes. So due to the continuous changing density of the atmosphere, sometimes our eyes receive a large amount of light and sometimes they receive a small amount of light coming from these point sources of light. Now again, what happens from the extended sources of light? Here also you have the fluctuations. Here also sometimes you receive a smaller amount of light coming to your eye and sometimes you receive a larger amount of light. But the variation in the intensity of light is very small in both the cases. So for the extended source of light, our eyes are unable to observe. They are unable to monitor those small changes in the intensity of light. Right? There is a large amount of light and there is a small amount of change over there, so we do not notice that. Whereas for the point sources of light or the star very far off, so for them what happens? For them the density changes. When the fluctuations are very fluctuate, even the small fluctuations in the intensity of light. Okay, even if there is a small fluctuation in the intensity of light, then also our eyes respond to it, and hence sometimes the star appears to us to be glowing and sometimes the star appears to be going dimmer. Okay, understood everyone?
Yes, sir.
Okay, so I want a written answer for this. Okay, everyone, this is your question for homework. So see what happens. Okay, so your homework here is you will write the reason for this. Why stars twinkle and planets do not. Got it? Now see, there are certain other phenomena. With this, we also observe a phenomena called advanced sunrise and delayed sunset. So that is also the atmospheric refraction. Due to atmospheric refraction only, we observe sometimes advanced sunrise and delayed sunset. That's every time. So see what is advanced sunrise and delayed sunset. In CBSE, this topic might have been deleted. This topic is not there for this session. Okay. But in other courses, yes, it may be there. So that's why I'm taking up advanced sunrise and delayed sunset. Okay, see. So what is advanced sunrise and what is delayed sunset? Obviously, when we observe the sunrise and sunset, so what is our criteria? When is the sun observable to us? During the sunrise, when are we able to observe this sun? Yes, criteria. How do we observe the sun? At what time?
Morning.
Okay, morning time. Yes, definitely we observe the sun during the morning time.
And before sunset.
Okay. So see, this the line I have drawn here. This is I have drawn as horizon. Okay. So this is the horizon. Horizon is the line where it appears to us that sun, the earth and the sky, they are meeting. That point is called as the horizon. So they appear to meet. That we observe if the sun comes above this horizon line. Okay, if you observe the sun to be coming above this horizon line, so then we say that yes, sunrise has occurred, and then only we can see this sun. So if the sun is above this, then only we will be able to observe it. And if the sun goes below it, so we will not be able to observe it. So if the sun is here, you will not be able to observe it. If the sun is here, you should not be able to observe it. Right? You will only be able to observe sun when the sun is above the horizon level. Got it?
Sir.
So what happens is, suppose the sun was moving like this. Suppose the sun was moving from this position, coming to the horizon, then coming to the top, and then again setting down like this. So sun was moving like this. Now in this situation, even when the sun is below the horizon, then what happens? See, here we have sun still below the horizon. Then due to the Earth's atmosphere, so see, due to the Earth's atmosphere, this is our Earth's atmosphere, and now due to the Earth's atmosphere, whatever sun's light, so whatever sun's light was supposed to become like this, and it was supposed to travel anyways here. Okay, it was supposed to travel like this, so we will not observe this sunlight. But this sunlight, while coming and reaching the Earth's atmosphere, it has to pass through the Earth's atmosphere. And when it passes from vacuum to air, it has to bend. And this ray of light, it bends now towards the normal, and hence, by bending towards the normal, it is able to reach our eyes. Got it? So see here, still the sun is not above the horizon. The sun is still below the horizon. That means it's not the sunrise. Okay, it's not sunrise. Sunrise has still not taken place, but we will be able to observe the sun. We will see the sun here in front of us. We will see the sun in the same straight line as light travels in a straight line. So it will appear to us that sun is here at the horizon, whereas actually the sun is still below the horizon. Okay, so can I say that I have seen an early morning? Okay, even when the sun is not above the horizon, I have seen the sun. So this is what we call as the early sunrise. Okay, so there is an early sunrise of about 2 minutes. You time taken by the sun to actually come up with this horizon is about 2 minute time. Okay, so we have an early sunrise of 2 minutes, and in the same way for the sunset also. During the sunset also, we observe the sun going down, and even when the sun is below the horizon, then also we are able to observe it. Okay, that means when we see the sun to be at the horizon, that is not the actual position of the sun. That is the apparent position of the sun. Okay, the position of the sun where we observe it, this is the apparent position. This is not the real position. Really, the sun is below this horizon. So that means what we are getting a delayed sunset. Delayed sunset means the sun has actually gone down. The sun is actually here. It has gone down, but even still it appears to us to be here. So that we call as the delayed sunset. Okay. Everyone has understood about the advanced sunrise and delayed sunset.
Yes, sir.
So see, these were the phenomena which we observed due to atmospheric refraction. Okay. One of the phenomena we observe is a color of the sky being blue in color. Then we observe due to atmospheric refraction, we observe twinkling of stars. We observe advanced sunrise, delayed sunset. Got it? So all these phenomena, they are all due to atmospheric refractions. Okay, one more thing is there, the color of sun. Color of sun, it includes both the topics. It includes the refraction as well as the scattering of light. See, during the morning time we observe the sun, it appears to us as red in color. Slowly the color of to orange, then yellow, and slowly it becomes white. So in some time it becomes a brilliant white, and it is brilliant white for the whole day, and then again during the evening time the color of the sun starts to change. Okay. So Sumukh, can you tell why the color of sun changes? Sumukh? Yeah, Sumukh, why the color of sun changes? Sumukh, are you there? Shubhansh?
Yes,
Shubhansh,
sir.
okay. So can you think of why the sun appears red during the morning and evening?
Because red color is scattered the least and it's the most visible color to us.
So how it is scattered the least?
Because other lights are mostly scattered away in the atmosphere.
So why not during the afternoon? Why only during morning and evening?
So it might be because blue color is has a shorter wavelength or something like that.
What happened? Blue color is
Blue color has shorter wavelength than red.
blue color has shorter wavelength. No. So what happens? Does it has the shorter wavelength, but during the afternoon, does the wavelength doesn't change? It still remains the same. So see what happens during the morning time. Okay, so that's why I tell you that keep your cameras on. Okay, if you keep your cameras on, I see that yes, you are there. Okay, even if your camera is not off and you are not responding, so it seems as if you are not there, right? Okay, we'll see this in next class. We'll see how it happens that the stars or the sun appears to be red during the morning and evening, and why not during the afternoon? A simple reason is that during the morning and evening, the sun's light has to travel larger distances through the Earth's atmosphere. So see, here it has to travel during morning and evening, it has to travel this much of distance. But during the afternoon, it has to travel only a small amount of distance. So the amount of scattering that occurs during the morning time is larger, and the amount of scattering that occurs during the evening, during the afternoon is smaller. Got it? Okay, bye everyone. We'll see again in next class.
Bye.
Bye. Thank you, sir. Bye.
Bye, sir. Thank you, sir.
Yes.